In this installment of the Vermont State Police Experts course, we are joined by two crash reconstructionists. These elite troopers account for less than 1% of police officers in Vermont. They have undergone intense master training to harvest field evidence at crash scenes to determine the physical dynamics of what occurred so that the event can be fully understood. Today, we learn about how to calculate a vehicle's speed by measuring available road evidence. Indeed. Welcome to the Experts course.
Hi, my name is Trooper Thomas Howard with Vermont State Police.
And I'm Sergeant Owen Ballinger with the Vermont State Police. Trooper Howard and I are members of the State Police's crash reconstruction team.
Today we're going to take a vehicle out to a parking lot. We're going to skid the vehicle from a certain speed to a stop, and from the evidence left on the roadway, we're going to determine what the minimum speed the vehicle is traveling.
The plan is to have a vehicle come in at a certain speed, and that speed we're not quite sure what it's going to be. At a point in time, the brakes are going to be applied and skid marks are going to be left on the road surface. And then the vehicle is going to come to a stop. After the vehicle comes to rest, we're going to go out and we're going to measure what the distance of the skid marks are on each side. And then once we know the distance and we know the coefficient of friction for the road surface, which we're going to call little f, we're going to come up with the speed of that car using this simple formula. Speed is equal to the square root of 30 times the distance times the coefficient of friction.
Sergeant Ballinger and Trooper Howard travel to a safe location to skid a vehicle. After preparing the scene, the skid test is ready to be conducted. To capture this test, both crash reconstructionists deploy unmanned aircraft systems, also known as drones, to document the aerial scene. In addition to their crash expertise, both troopers are certified drone pilots. This is drone footage taken from the Hawk's Nest position. Keep an eye on the center of the screen for the approaching skidding vehicle. As the vehicle's brakes are applied, the non-rotating tire skids across the pavement, depositing rubber on the asphalt in its wake. Trooper Howard's chase drone offers us a unique vantage point of the same skid test. Again, note the rubber that is deposited on the roadway. This final perspective offers a closer examination of the force involved even in relatively low-speed dynamic braking. As a reminder, this was filmed on a closed course with professional personnel. Do not attempt this on your own. With the skid test now complete, Trooper Howard explains how he and Sergeant Ballinger will begin this investigation.
So we just performed a skid test out here. We had a car come in at an unknown speed, and then after it reached that certain speed, the brakes were applied, the wheels were locked, and then it skidded to a stop, which is where it rests right now. After the car came to rest, we want to determine how fast the car was going based off of the physical evidence at the scene. So the way that we do that is we're going to measure both of the marks, the left and the right, to see how far the car traveled prior to coming to rest. So myself and Sergeant Ballinger, we came out here, and we got down and tried to identify where the left tire marks began and where the right tire marks began. As you can see, the tire marks are lighter in the beginning and then get darker as the vehicle comes to rest. And we've identified the beginning of each of the marks with the letter L and R for left and right. Now that we know where the skid mark began, we're going to go to see where the car came to rest, and we're going to measure the distance traveled from the beginning of the skid mark to the end, and that's what we're going to do now.
As Trooper Howard maneuvers the measuring tape, Sergeant Ballinger talks us through the details.
So what we're doing here is we're measuring the length of the skid mark. And the way we do this is we follow the contour of the skid. This is a relatively straight skid. It travels in a straight direction. If one of the brakes was not functioning properly, the skid mark could be more curved, in which case we would follow the contour of the skid. But this is a relatively straight line skid, so we're just measuring the length of it in the direction that the vehicle was traveling. What's the measurement?
68.5 feet.
68.5 feet, 68.5 feet. So we always draw a little field sketch of what we're looking at. So we have the car facing the direction that it was going, and we sketch out the skid marks, and then we're going to keep track of the length of the skid marks on our field sketch. Are we good on this side? Yep. Okay.
The experts then measure the vehicle's left skid mark. With the skid distances obtained, their attention now turns to determining the coefficient of friction.
So we have a drag sled, and what this is it's a section of tire that's been filled with cement, and we're going to pull it in the direction that the skid was the skidding vehicle. So the first thing we're going to do is we're going to weigh our drag sled. So we're going to hold that up. We're going to get a reading.
26 pounds.
So it weighs 26 pounds. And we're going to pull the drag sled in the direction of the skid. Right next to it. So we're going to need Trooper Howard to read the scale.
21 and a half.
And we're going to do this several different times and take an average of the reading.
21.2.
And when you're using a drag sled, it's important that you pull it the direction that the skid was traveling, and you want to make sure you're not lifting it up. You have to drag it straight, and we're just recording the amount of force it takes to slide this weight over this surface.
4.9.
So this works really well on pavement. You can also use it on gravel roads, grass, snow, ice, and all we're trying to do is determine the amount of force required to move the drag sled over the surface.
6.5.
After taking 10 measurements with the drag sled, the experts are now ready to conduct their calculations.
All right, welcome back everyone. We are back at our office where we're going to analyze the data that we obtained at the scene. So we skidded a car which was traveling at an unknown speed. We measured the distance of the skid marks that were left on the road surface, and we also performed a series of tests using our drag sled. So now we're going to take a look at the data from our drag sled tests to calculate the coefficient of friction for that particular road surface.
As Sergeant Ballinger stated, we're going to use the data collected at the scene with the drag sled to come up with a value for the coefficient of friction for the road surface, basically where the rubber meets the road.
Right now we're going to calculate what the coefficient of friction was for the road surface, as we just discussed. The formula we're going to use is the coefficient of friction, which is little f, is equal to the average force needed to pull the drag sled divided by the weight of the drag sled. If everyone recalls when we were at the scene, the weight of the drag sled is equal to 26 pounds. And now we need to come up with what the average force was to move that drag sled. And Sergeant Ballinger has the values which we're going to average right now. So we're going to say F, which stands for the force required to move the drag sled, measured in pounds. And what were those values?
21.8,
21.8,
21.2,
21.2,
24.9,
24.9,
22.9,
22.9,
23.1,
23.1,
25.6,
25.6,
26.5,
26.5,
23.6,
23.6,
24.5,
24.5,
and 24.7.
24.7. From these, we're going to come up with what the average force was used to move the drag sled. To come up with an average, we're going to add all these numbers up to come up with a total, and then we're going to divide by the number of samples that we have. And in this particular instance, we have 10. So if we want to come up with the average force, like I was just saying, we have to add all those up. And Sergeant Ballinger, what's that?
238.8.
238.8, and we're going to divide by the number of samples that we have, which was 10. So the average is going to be 23.88. Now, using the average, we want to come up with little f, right? The coefficient of friction. So to come up with little f, we're going to take the average force, which we just calculated, which is 23.88. And we're going to divide by the weight of the drag sled, which we showed you all at the scene, is 26 pounds. If one notice, we're going to be dividing pounds by pounds. So the value that we come up with is going to be a unitless quantity. So the coefficient of friction for the roadway, which is rubber and asphalt, is
0.91.
0.91.
So now that we've obtained our coefficient of friction of 0.91, we're going to make some room on our board here.
All right, we have our coefficient of friction. Let's remind ourselves what we had at the scene. So we had a car that we skidded across the asphalt and it came to rest. We had two skid marks that we saw, and there were two different distances. We had a left skid, distance on the left side, and we had a right skid, distance on the right side. From these distances, we're going to come up with an average distance the vehicle traveled from the beginning of skid to where it came to rest. What was the distance on the left, Sergeant Ballinger?
64 feet and 4 inches.
64 feet and 4 inches. And then on the right?
68.5 feet.
68 feet and 6 inches. Recognizing that we want to try to convert these to decimals because they're going to be easier to average as we write them down over here. Distance on the left side is equal to 64.33 feet, and the distance on the right side is equal to 68.5 feet. Now, I just mentioned that we want to average these together, which is exactly what we had done in the previous section when we were coming up with the coefficient of friction. So the average distance that the vehicle skidded is equal to 68.5 plus 64.33 divided by 2. So our average distance is equal to
66.4 feet.
66.4 feet. We've come up now with our coefficient of friction value and the distance, the average distance that the vehicle skidded. So let's write down all the knowns that we have. So make a little box up here. All right, knowns. Little f, which we just calculated, which is the coefficient of friction, is equal to 0.91. And the distance, the average distance that was traveled, is equal to 66.4 feet. Now that we have both these values, we can come up with the speed, the minimum speed that the vehicle is traveling, which is what we were all trying to look for. So let's erase the stuff that we have down here. As we discussed early on when we were opening up with this segment, speed is equal to the square root of 30 times the distance times the coefficient of friction. We don't know S, but we know D and F, so let's calculate it now. So the speed is equal to the square root of 30 times the average distance, which is 66.4, times the coefficient of friction, which we calculated, which is 0.91. We multiply 30 times 66.4 times 0.91. We're going to take the square root of
1,812.72.
0.72. We're going to take the square root of that value, and the speed, the minimum speed that the vehicle is traveling, was
42.5.
42.5 miles per hour.
In summary, let's revisit the experts' vehicle speed investigation. They measured both the right and the left skid marks. To determine the average length, they added together both measurements and divided by 2. This gave them an average skid mark distance of 66.4 feet. Next, the experts needed to determine the coefficient of friction, that is, how easily the tires slide against the surface of the roadway. Using their drag sled equipment, they took 10 separate measurements. They calculated the average by adding together each measurement and dividing by 10. Then, they divided the average by the weight of the drag sled, 26 pounds, to conclude that the coefficient of friction was 0.91. By plugging these two values into their speed calculation formula, they determined that the vehicle was traveling at a minimum speed of 42.5 miles per hour.
We hope you found this segment interesting, where we measured the distance of skid mark that was left on the road surface, we obtained the coefficient of friction, and we calculated a minimum speed that the vehicle was traveling in order to leave that distance of skid mark on that road surface. We used some techniques that are taught in math classes. Some students may think, while they're performing these calculations, when am I ever going to use this again? And we hope that this is an example of how math is used in a real-world application. Trooper Howard and I use these formulas on a daily basis to determine things like how fast a vehicle was traveling. In this instance, we calculated that a vehicle was traveling at 42.5 miles per hour. If the speed limit was 25 or 30 miles an hour, in the area where these skid marks were deposited, we may have a problem there.
This concludes this experts segment. If you have any questions, please leave them in the box below. Myself or Sergeant Ballinger would be happy to answer them. Please be safe, check on others, and we hope to see you again.